This is Algebra 1, 8.3, guys. We're multiplying polynomials. Or should I say we're continuously multiplying polynomials. We did that last lesson where we multiplied a polynomial by a monomial. So all you had to use was the distributive property. Well, you can use the distributive property again today, as this first slide is showing. But a lot of us probably have a different way of multiplying a binomial times a binomial. 2 terms times 2 terms. But we're going to take the long approach here first, because let's just understand why a certain approach works, or why it's the same, or how it's the same. So what we're going to do is we're going to use the distributive property. Now, if I asked you, or should I say, if I asked you or told you to ignore the fact that that 4 was there, right? I'm going to cover it up. Would you know what to do with 3m times m plus 5? What are you going to do? Distribute. If I cover up the 3m, what are you going to do with the positive 4? Distribute it. So this is what I propose. If I'm going to use the distributive property, I am going to act like that exact thing's happening. I'm going to take the term of 3m and I'm going to multiply it to the second group. Taking the long approach here. What I'm doing is I'm multiplying the first term to the whole second group. I then can go back and say I'm going to do the same thing with the second term. So it's plus 4 times m plus 5. Can everybody see that I just basically took every term in the first group and distributed it to the second group? Doesn't that problem look a lot like what you guys just did yesterday? What would I do with 3m and 4 now? Distribute again. So this is where you don't keep making the rainbows. You do it one at a time. 3m times m? No. 3m squared. 3m times 5? 15m. 4 times m? 4m. And 4 times 5? 20. The last thing you should always do is gather like terms, put it in standard form. It's already kind of in standard form, as highest to lowest, just that you should see 15m plus 4m would end up leading us to 19. So plus 19m plus 20. There's our answer. Does anybody know what the name of that type of problem is, or polynomial? Starts with a Q.
Quadratic.
Quadratic. Most of the time, I'm not going to say all the time, most of the time when you multiply two binomials, you'll get a quadratic. Or should I back up and say, that happens if you multiply two binomials of the first degree. 2 first degrees multiplied together will give you a second degree. A second and a third degree will give you 5th degree. So just be careful, we're using those exponent rules. So, I want you guys to do the exact same thing with 5y minus 2 and y plus 8. I'll give you guys a couple seconds to try that on your own. Okay guys, what's the first step supposed to look like, Monica? Okay.
Second equation.
So what's it going to look like?
5y.
Mm-hmm.
Parentheses, y plus 8.
Y plus 8.
Close parentheses.
Yep.
Minus 2.
Minus 2.
Parentheses. Y plus 8. Parentheses.
Okay, so we're distributing the first terms of the group to this last term, or the terms of the first group get multiplied or distributed to the second group. And from here, we're going to take each one of those terms and distribute them in. Nick? Yep. Squared. And then 5y times 8. 40 what? 40y. 2, negative 2y.
Then
negative 16. Everybody's okay with this? And you guys notice what seems to be happening? The middles can be put together. Now again, this, it's not always like that, but a lot of times it's like that. And what's 40 minus 2?
38.
So it's plus 38y minus 16. Done. So what we're going to do now is probably use something you guys probably all have learned about already. The 4-letter F word. FOIL. I don't know what you guys were thinking. The FOIL method. So, F-O-I-L. Without looking, guys, without looking at the screen, what does FOIL represent? First, outside, inside, last. The book says first, outer, inner, last. But I remember it as inside, outside, inside. Doesn't matter, same thing. So, F stands for first. I multiply the first term in each group. O is for the outside terms, the ones furthest away from each other. O. I is the innards, the ones that are next to each other in the brackets or parentheses. And L, the last terms, the last two in the group, get multiplied together. You multiply them, you add them, you got yourself quadratic when you gather up like terms. So what we're going to do is we are going to practice foiling. And here's the cool thing. It basically eliminates that other step of having to write it down as I'm distributing through. But I still need to see the bridges. I'm not going to put all of the rainbows on first and then do the work. I'm connecting, I'm writing. I'm connecting and multiplying, right? So, first, now if you guys need to, write FOIL down. Write it so you can see it. And so, first, F, first, x times x. Squared. Outside, x times negative 4. Negative 4x. Inside, 3 times x.
3x.
And last, 3 times negative 4. And what are you going to do with middles? So you end up with negative x minus 12. Done. Hey guys, look at the work we just did there. It's not, some of it overlaps a little bit. Take a look at that work we just did and look at the process that you did last time. What did I do with the first term in the first group?
Distributive.
To both
Other term.
things in the second group, right? Isn't that kind of like the second step of what we did last time? And then I went back and I multiplied the 3, or distributed the 3 through. So x went first, all the way through. 3 went through second, and I multiplied them. So, I'll give you guys a couple seconds here, and we'll do part B. Okay guys, in the second one here, we're going to do FOIL. I'm going to connect them in a slightly different way. As in, I'm still going to make the connections, but I'm not going to use the same order as we did with part A here. So first means first, right? So let's connect those. I'm going to change colors so you can see this. Purple, okay, we'll go purple. 5a times 3a is
15a. That sounds
15a squared. Outside. Outsides. 5a times negative 4 is negative 20a. Inside. which is plus 6a, and
Schwartz. 2 times 4.
last
-8.
minus 8, and so you get 15a squared minus
No, 16.
14a minus 8.
I got that.
Hey guys,
It's a cat.
they call this Billy binomial
Why?
because it looks like a
That's a
Cat?
face.
I'm putting that on my test.
That's a cat.
Okay,
It's a cat.
Bill. This is another way. If you can make a face with the connections, therefore you know you did it right. You got them all connected. Notice that's what they did up here. You got the little eyebrows. You can almost think that the person's wearing glasses with a nose and a mouth. Some people see it, some people don't. I don't generally do it that way. I go with method A here, with taking the first one, distribute it all the way through, take the second term, distribute it all the way through. To me, that's a little bit more logical in a flow, okay? So, why is this important? Why are we talking about foiling? Why are we talking about distributive method? Is because you can multiply any polynomial of any size to another polynomial of any size. And all it comes down to is making sure you distribute correctly. So now let's do a binomial times trinomial, or a trinomial times binomial, it doesn't matter, or a trinomial times trinomial, or a 10th term polynomial times a 10th term polynomial. It doesn't matter. You just keep doing this over and over and over and over. Now, I'm going to default, I actually call the first one here, I like to kind of affectionately call that the double distribute method, because all I'm doing, just like we set up in the very, very beginning, I'm taking the first term and I'm distributing to the second group. Not once, not twice, but 3 times, because there's 3 terms. I then take the -5 and do the same thing. All 3 terms. I'm distributing each member in the first group to each member in the second group. How many terms are in the first group? How many terms are in the second group? What's 2 times 3?
6.
How many terms are we going to end up with?
6.
6. And then we're going to condense them, gather up like terms. It'll be smaller. Just like the 3 by 3. You should have 9 terms when you originally got it all multiplied. So, we just talked about this. 3x times 2x squared is 6x cubed. 3x times 7x, 21x squared. 3x times a -8, -24x. I now go through and distribute the -5. -5 times 2x squared. Squared. There's no other x's, right? Just the x squared. -5 times 7x. X. And -5 times -8.
40.
Plus 40. Negative makes a positive. At this point, guys, I want to put everything in standard form. Highest to lowest power. So, I think x cubed is the highest exponent. Next, x squareds. I have 21 of them. I subtract 10 of them. I now have
11.
a positive 11 x squareds. -24x minus 35x. So -50. Take away the negatives, so it's 24 plus 35.
59.
So it's a -59x plus 40. And you're done. We had 6 original terms, but some of them combined up, and now we have 4 terms. Notice that the degree is 3. The leading coefficient's 6. The constant is 40. All things that you should have taken from 8.1. Any questions on that, guys? I want you guys to try that last one. So, we should have 6z squared times 3z cubed, which ends up being 18z to the 5th, 6z squared times a negative 2z, negative 12z cubed, 6z squared times negative 4, squared, okay. I'm going to run out of room, so I'm going to have to write underneath. I could shrink this, but I'm not going to. So now I've got to go to the 5z. So negative 5z times 3z cubed. Negative 15z to the 4th power. Negative 5z times negative 2z squared. Negative 5z times negative 4 plus 20z. Okay, now I've got to go and do the negative 2. So negative 2 times 3z cubed. Negative 6z cubed. Negative 2 times negative 2z is 4z. And negative 2 times negative 4?
8.
It's plus 8. Now we're just going to go through, and they're all added or subtracted here. We've got to gather up like terms. If I had more room, I would have wrote this all in one line across there. There are 9 of them, right? Because 3 times 3 is 9. There are 3 numbers in the first group that needs to be multiplied to 3 numbers in the second group, which results in 9 multiplications. You have them. We now try to put as many of them together as you can. What's the highest degree? 5. So 18z to the 5th. Any others? Okay. Next would be 4ths, right? We'll go this way. Any other z to the 4ths? So it's minus 15z to the 4th. Okay, anything else? What's next? Well, here and here. What's negative 12 minus 6? Negative 18z to the 3rd. Z squared, negative 24 plus 10. Plus 24z plus 8. Boom. Takes a while, but it's not difficult. You just keep going. Tomorrow, we're going to talk about special patterns when you multiply special things together. That the sooner that you learn the patterns, the easier the rest of the 3 and 1/8 years is going to be easier here. Otherwise, homework is worksheet 8.3. All. Have a great day.